developers, and welcome to day 4 of this ROS2 Jazzy Learning Week. Welcome everybody to one more day in this awesome learning week. We are getting to an end, but also we are getting to the most interesting sections or parts of this learning week. So today we are going to be talking about ROS2 topics, which is probably one of the most important points. So make sure to pay attention and follow this class. So yeah, hello everybody. Let me already switch here to my PC screen so that I can start see your messages in the chat and everything. So let's go there. Let me come here to the Learning Week streaming page. There we are. Okay. So hello everyone. Hello from Canada. Hello from China. Okay. I don't know why here the streaming is not playing. Let me refresh the screen. There we go. Okay. Okay. So yeah. I can see some names that I know that they have been around in previous days, but probably we have some new people today. So I'm going to very quickly explain how to get started with the class. So today we are going to be following the class using a Roject. Roject is the name that we have given to a self-contained ROS project. And these projects are based on the cloud, and they are easily shareable with anybody. So I have created a Roject for today's class, and I want to share it with all of you so that we can follow today's class together. Then how to get this Roject? It's very easy. All you have to do is to click in this button that appears here right below the stream screen, which says Open this Talks Roject. So I'm going to create here, I'm going to click here myself right now. And then this is going to do a couple of things. First of all, it is going to redirect you, as you can see here, to the Roject main page. Here, the Roject is loading, the Roject environment, and here in the right side, you have the chat, you have the stream and everything. So I'm going to move this to another page because I want to have more space in my Roject to show everything properly, but I'm going to open anyways the streaming here so that I have the chat and I can see your comments. All right, so let me minimize this here. There we go. Okay, then first of all, you are going to be redirected to a Roject. This might take some seconds to fully load. And a second, also, I already explained this yesterday, but let me explain this again. Also, a copy of this Roject has been added to your account. Then if you come here to the main, the construct page, and you go in the left side menu to the My Rojects section here, if you click here, you are going to see the Roject for today's class, which is this one, ROS2 Learning Week, Day 4, Understanding Topics. This means that you have this copy of the Roject in your account forever. Not only for today's class, but you are going to be able to revisit it next week, next month, whenever you want. Okay? Then, yeah, so the very first thing before we get started is that everybody opens his Roject, okay? I have here many things because this was the previous configuration, but once you open the Roject, what you are going to see is the Jupyter notebook, which is loading for me right here, okay? So this is the notebook which contains all the instructions, commands, code, everything that we are going to be doing and using during today's class. And basically what I'm going to be doing is to follow this notebook, okay? So if at any point during the class you get lost, you can come back here to the notebook to see what we are doing step by step. Also, you are going to probably see a shell, a terminal, a Linux terminal, open automatically here and start installing some things that are required. All right. If this doesn't open automatically, don't worry, because it's going to install all these packages whenever you open a terminal for the first time. Okay. Yep. So far, so good. Is it clear? Has everybody opened his Roject? Hello from India. Hello from Barcelona. Hi, can we access day 3 Roject? Well, if you have the Roject, then yes. Probably the link to the Roject is going to be in the YouTube video, I would guess. So if you didn't attend to yesterday's class, then you can get the Roject probably in the YouTube video. Okay, and if you attended to yesterday's class, then you are going to have the Roject in your My Roject section here. Yeah, you are going to find yesterday's Roject like this. All right. Hi from the US. Hi from Peru. Okay. Yes, all clear. Yes, yes. Okay, then let's continue. Second step, once we have the Roject loaded, the next step is to start our simulation. So today we are going to be working and interacting with a ROS2 based simulation. So we need to start it. Then in order to start the simulation, very simple, all you have to do is to execute these commands that appear here in the notebook in the terminal. So what you can do is to just select the commands, copy them, and then come to the terminal and paste these commands like this. Okay, and then you execute them and the simulation is going to start launching. You are going to see some messages appear here, and after some seconds, you should see the simulation window automatically pop up here in the screen. Let's wait for some seconds, and there we go. Here I have the simulation window automatically opening. Here, there we go. Here you have the gazebo simulator, and then you can maximize the simulation window to see it better. And then here you are going to see the world environment, and here you can see it in a small, is the ROSbot XL robot by Husarion, which is the robot that we are going to be using for today's class, okay? You can zoom in to the robot to have a closer look and move around the simulated world. Let me zoom a little bit into the robot. Too much. Let's get... There we go. There we go. Okay. So here we have the ROSbot XL robot. Okay? And let's continue. Okay, and then, as always, before getting started, let me remind you about our Robotics Developer Masterclass program, okay? Very important, because today is the last day of the early bird discount, okay? Then if you don't know about our Robotics Developer Masterclass, this is a job-ready program in 6 months. So it is a full program where we are going to teach you from the very basics. You don't need any previous knowledge. We are going to teach you from the very basics until the most advanced concepts, such as autonomous navigation, manipulation, robotic perception, control, and many other things, such as DevOps tools, more focused into working at a company, and many more. But the goal of this masterclass program is to take you from zero to being job ready. So we are going to prepare you to be able to work in any robotics company of the world, to start your robotics career in 6 months. And as I was saying, today is the last day of the early bird registration. Yeah, this is ending on August 1, which is today. So last day for the for this €100 discount. Regular price is 900 euros a month, and if you enroll before August 1 ends, so basically today is the deadline, then you are going to have a 100 euro discount. But not only this, but for the ROS2 Learning Week, we are also giving away this discount coupon in order to get 100 euro extra discount per month. So at the end, from 900, you would be paying 700 euros a month. Taking into account that this is a program which is meant to be completed in 6 months, it is a lot of money that you are going to save. All right. So if you are thinking about getting into the robotics world, or maybe you want to switch your career from another path to the robotics world, then this Robotics Developer Masterclass is a great opportunity for you, and we have a new batch starting in September. So, then having introduced the Robotics Developer Masterclass, let me go back to the class, and we should be now ready to get started, okay? So before actually getting started with the class, I want to make sure that everybody, again, has the Roject opened and they have the simulation properly loaded, okay? Very important, because today we are going to be interacting a lot with the simulation. So let me go back to the chat. I have a basic doubt. What's the difference between ROS2 Jazzy and Foxy? Well, they are different distributions of ROS2, yeah? So ROS2 is continuously improving, and every year they release a new distribution with some improvements, okay? Then ROS2 Jazzy is the latest release, which was released, I think, a couple of months ago. So it's the newest release. And Jazzy, it was released a couple of years ago, okay? I think it was, Jazzy, Humble, and then, it was Foxy, Humble, and then Jazzy, if I'm not wrong, okay? So if you are getting started with ROS2 now, the recommended version to start with is Jazzy, because it is the latest one, okay? Foxy, it's already a little bit deprecated. Steven is asking, okay, so you have found it in the instructions, great. Okay, so is everybody ready? Everybody has the simulation loaded? Yes? Let me know here in the chat, please, so that I can continue. Okay, John says yes, also Tomas. Okay. Awesome, so everybody is ready. Okay, then let's get started with the class. So, yeah, then yesterday we introduced the concept of ROS2 nodes, yeah? If you attended to yesterday's class, you should be already familiar with the concept of ROS2 nodes, yeah? So whenever we start a ROS2 program, this is going to also launch, let's say, a ROS2 node, okay? Then usually in a robotics application, we are going to have several ROS2 nodes, yeah? For instance, let's imagine a robot, yeah? So we are going to have a ROS2 node for the laser, yeah? In order to capture the laser data. We are going to have another ROS2 node in order to control the wheels of the robot, yeah? So that we can send velocities to the robot. We are going to have another ROS2 node, for instance, to control and to get the information from the camera, yeah? And many more, okay? So usually in a robotics application, we are going to have several ROS2 nodes. Then these ROS2 nodes need to share information between them, okay? It is crucial that these nodes are able to share information between them. Then they can do this, they can share information between them using different methods, but probably the most typical and important and core one in ROS2 is topics, yeah? So Topics are used in order to share information between nodes. Okay? Then you can publish information into a topic, or you can either read information from a topic. Okay? But the general idea that you should get in your mind right now is that topics are used in order to share information between different ROS2 programs, ROS2 nodes. Okay? Then let's start getting already some practice and hands-on. So we are going to start reviewing some very basic topic commands. Okay? Then here, let's go back to the terminal. Here we have our simulation running. So let's leave this one here because in this terminal is where all the processes related to the simulation are running. So if you close it or anything, or if you stop it, then the simulation is going to die, and we don't want that. So in order to be able to execute more commands, we are going to open another terminal. Yeah, you can do this very easily by clicking on this plus icon here to create a new terminal. There we go. Okay, then here we have a new terminal where we can start writing commands. So first thing, we are going to source our ROS2 distribution, which is Jazzy in this case, and then let's start by running the ROS2 topic H command. Yeah. Whenever we want to run a command related to topics, we are going to use the ROS2 topic keywords, okay? And if we provide the -h argument, then we are going to get information about all the options that the ROS2 topic command provides, yeah? You are going to see here that there are many different, like BW, to display the bandwidth used by a topic, delay, echo, find, hz, info, list, pub, type, okay? So all these are the different options that I can use with ROS2 topic. Then we are going to be checking some of them, the most important ones. And the very first one that we are going to try is ROS2 topic list, all right? So let me execute this command here. So if you remember, yesterday we checked the ROS2 node list command, right? And this command, what it does is to provide a list of all the nodes that are available right now in the ROS2 system, yeah, which are all of these. And we also mentioned that these nodes are related to what? To the simulation that it's running here, okay? Then the ROS2 topic list, what does it do? It does. Well, it does provide a list of all the available topics that we have right now. Yeah? Okay, so right now in our ROS2 system, which is the simulation, yeah, we have all these topics available, okay? And each topic is going to be providing some kind of data, yeah? For instance, we have here the scan topic. In this topic is where we have the information, the data, captured by the laser of the robot, okay? We have here some camera topics, which are related, obviously, to the camera, okay? Another important topic is the command belt topic. This one here, Rosbot Excel-based controller command belt. This topic is used in order to send velocities to the wheels of the robot, in order to move the robot, okay? So, ROS2 topic list is the command used in order to get a list of all the currently available topics, all right? Then, we can get information about a specific topic with the ROS2 topic info command, yeah? ROS2 topic info, and then we specify the name of the topic, which is this, that we want to get information from. For instance, we can get information from the scan topic, yeah? And then we can see here the type that this topic uses, the publisher, and subscription count, okay? So as I said at the beginning, in a topic, you can either publish information to that topic, or you can subscribe to that topic in order to read the information from that topic. Yeah, we are going to get to practice more with this later, so don't worry too much right now, okay? And each topic has one type associated, yeah? So through a topic, there is data, there is information flowing, right? And then this information has a type, yeah? It's not the same information, the information related to a camera than the information related to a laser than the information related to wheel velocities, right? Then each type of information is defined with a different type of message, okay? Yeah? So far, so good. Let me have a quick look here at the chat. I can see some messages. Does it list all topics or just topics that are being published right now? Okay. That's a good question, Franco. I refer to the ROS2 topic list. Yeah, I understand. So here, I can see that Kailash is already answering to you. Maybe all the active topics associated to active nodes. Yes, exactly. So it's not exactly all topics that are being published right now, but all the topics that are active. Yeah, I like the explanation from Kailash. For instance, let me give you an example. Okay, not yet. Let me wait a couple of minutes, and then I will give you an example exactly related to this. Okay, Franco? But before, I want to introduce a couple of ideas. Justin is asking, not sure if this is too far off topic. Is ROS2 and Gazebo suitable for drone swarm simulation? Is ROS2 and Gazebo suitable for drone swarm simulation? Yes. It is. Yeah. Justin. Yes, very good. Okay. All right, then let's continue. Let's continue a little bit more. Then, yeah, ROS2 topic info. Yeah, so for instance, if we check the information of another topic, now you are going to see that the type is going to be different. Yeah, so the scan topic uses this type of message, and the ROSbot Excel-based controller command bell topic uses this type of message. Okay, and if we check another topic, probably it's going to have a different message. For instance, one topic related to the camera. Yeah, this one uses another type of message. And then you can see that there are, for instance, in the scan topic, we have one publisher count. What do you think is this? The number one, what it is? It says 1. What is this number referring to? 1 what? The publisher node, 1 LiDAR or 1 sensor, topic scan that publish laser message. 1 node that outputs some message to that topic. Exactly. 1 active publisher, 1 node. Okay, very well, very well. You get the idea. So this 1 refers to 1 node. There is currently 1 node that is publishing information into this topic. And there is another node who is subscribed to the information of this topic. Okay? Now, for instance, if we check this other topic, the command bell, we have 1 subscriber. So there is 1 node who is subscribed to the information of this topic. It is reading, but there is no node publishing to this topic. Yeah? And on the other side, for instance, in the camera color image raw topic, we have 1 publisher. So there is 1 node publishing information, but there is no node subscribe to this information. So we have all the examples. Then this answers your question, Franco, right? Because for instance, in the common bell topic, there is nobody publishing information. But anyways, it is appearing in the ROS2 topic list, right? It is appearing because there is somebody who is subscribed to this topic. Therefore, we can say that this topic is active, okay? Even though nobody is publishing information into this topic. Yeah? Then, how can we publish information or subscribe to the information of a topic? So basically, in relation to a topic, there are two main actions that we can do. Yeah? Either we can publish information into the topic, or we can subscribe to a topic to read the information that is being published there. Okay? Then we can do this in two ways. The fast way is using the command line. So using some commands, we can publish information or subscribe to the information of a topic, or we can create a program that does that, okay? Then we are going to start by using the command line, and later in the class, we will create programs that do this, okay? Then here is where we can introduce the ROS2 topic echo command. The ROS2, so we get, for instance, ROS2 topic H, we can see that there is the echo command. Here it says, output messages from a topic, yeah? So basically, we can do a ROS2 topic echo, and this is going to subscribe to a specific topic. For instance, if I subscribe to the command bell topic, yeah, if I subscribe to this topic, what do you think is going to happen? What do you think is going to happen if I subscribe to the command bell topic? Martin is asking, on ROS1, we could see which nodes the topic publish subscribers to. Is it the case also in ROS2? Yes. In ROS2, you also can do that. I will show you now. Can we say a topic is called active when a node is published or it or subscribe it? Yes, because we can say that. Yes. No message. You will be reading the current value of the velocity of the robot. You will see velocity. You will be able to publish some command to move the robot. No. Print command bell of robot. No node is providing velocity commands. We will see the velocity reading. Exactly. So this is the correct answer. No node is providing velocity commands, so no messages, right? A moment ago, we check the information of the command bell topic, and we saw that nobody is publishing there, right? So if I subscribe to this topic, I can see nothing. No messages. Why? Well, because nobody is publishing messages into this topic, yeah? Nobody is publishing messages into this topic. And let me go a step further. If I come here, if I open another terminal and I run ROS2 topic info, what am I going to see now here? Voila. Still, nobody is publishing information, but now I have two nodes subscribe to this topic, right? One, it is me. It is this command that I am running here, which is subscribed to this topic. And the other one is another node, okay? That right now we don't know which one it is. But somebody was asking, can we know which node it is? Yes, we can. So now, for instance, I have stopped my command. So if I check again the info, I'm going to have only one node. Okay? Then how to know what node is subscribed to this topic? For that, you can use the -b argument. Okay? If you add the -b argument, then you are going to get more information about this topic. See? So, publisher count is 0, subscription count is 1, and the node name which is subscribed to this topic is this one. This node, ROSbot Excel based controller, it is subscribed to this topic. Okay? Yeah? Is it clear, this? Is it clear? Yeah? Very clear. Yes. Okay, then let's continue. Let's continue. Okay. Then we were saying, right, that each topic has a type of message which is associated to it, right? Then I want to have some information in this topic, right? Because I don't like subscribing to a topic and not having information on it. Then let's publish information to that topic, okay? Then what command can I use in order to publish data into a topic? Well, if we check here the available commands, we can see this pub command, which says publish a message to a topic. Okay. But before being able to publish a message to a topic, I need to know something, right? What do I need to know before being able to publish information into a topic? The message structure, exactly. The type, yeah. I need to know what type that topic uses, right? Then, for the case of the command belt topic, the type that this topic uses, I know it is this one. Geometry messages, message, twister stamped, yeah? But what is the structure of this message? Well, I can check the structure of a message with the following command. ROS2 interface show. Yeah? ROS2 interface show. Again, the ROS2 interface command is the one related to messages, to types. Okay? Then I can also run ROS2 interface H, for instance, to get all the available commands. Okay? So for instance, if I run ROS2 interface list, I'm going to get a list of all the different types of messages, types of interfaces that are available in ROS. As you can see, there are lots of types of messages, right? But if I want to know the structure of one specific message, I can use the ROS2 interface show command. Yeah? Then if I execute this command with the twist stamped, then I'm going to get the structure of this message. See? So the structure of a twist stamped is a header and then a twist containing two vectors. One for the linear velocity and another one for the angular velocity, right? The linear velocity is going to provide linear velocity to the robot, yeah, in order to move forward or backward. And the angular velocity is going to make the robot rotate. Yeah? So, we have this other command, for instance, which shows the structure of a message. Okay, this is a trick that you can use in order to publish a message. Yeah. So if we execute, so the interface show command shows the structure of the message, right? But if we use the ROS2 interface proto, then this gives us the exact structure of the message, okay? So now I can use this structure to publish a message. For instance, I can do ROS2 topic pub, okay? ROS2 topic pub, then I indicate the topic where I want to publish to, right? Which is ROSbot XL base controller command bell. And then I have to specify the type that I'm going to publish, which is geometry messages, message twister stamped. And then I can copy and paste the structure, okay? For instance, here, I can copy directly and paste the structure, okay? And this is not going to allow me to change it, but you can publish the velocity with zeros, like this, enter, okay? And then now you are going to be able to edit it, okay? So for instance, let's say that I provide an angular velocity, like in the example here, where we are providing an angular velocity of 0.5. What is going to happen if I publish this message with an angular velocity of 0.5 to the command bell topic? What is going to happen? Can somebody tell me? Rotation, says Justin. Rotate? Okay, so the robot is going to start rotating, right? The robot will rotate. Okay, let's try. So let me put the simulation here, and let me execute this command. Okay, and you were right. The robot starts rotating. Very well. And what else is going to happen? Well, first of all, if we come here to the echo, let me stop it and rerun it. Now, if I run the ROS2 topic echo command, I'm going to see the messages that are being published in the topic, yeah? The messages that I am publishing in the topic, right? Yeah? So now I can see the messages, and furthermore, if I run a ROS2 topic info of the topic, which is this one, what am I going to get? Oh, not this. ROS2 topic info. I just want the name of the topic. There we go. Yeah. So now I can see that I have one publisher, which is, of course, this one, and two subscribers, my ROS2 topic echo command and the note that we saw earlier that is subscribed to these commands. Yeah? Right? So let me stop the commands now, and my robot is going to stop, as you can see. Okay, yeah, so this is the structure of the ROS2 topic pub command. You specify ROS2 topic pub, then the topic name, the interface name, and then finally the structure of the message. Yeah? Okay, now let's check another topic. ROS2 topic info scan, for instance. This one has already one publisher. So if I do a ROS2 topic echo of scan, what is going to happen? That I'm going to already start seeing information here, right? Yeah? Okay, and also I can check the information. I can check the structure of the laser scan message, right? Because the, no, not the echo, sorry. I wanted the info, there we go. So the scan topic uses this message. So I can check the structure of this message with ROS2 interface show. And here I can see that this interface, this type of message is a little bit more complex, right? We have a header, then we have here some information like the angle mean, angle max, angle increment, scan time, range mean, range max, an array of ranges, and an array of intensities. Okay? So all this information is related to the specifications of the laser, yeah? What is the minimum range of the laser? What is the maximum range? What is the minimum angle, the maximum angle, and the angle increment between each laser ray, right? And here, in this ranges array, I'm going to have a list with all the readings from every laser ray, okay? If you attended to the Python class, which was day 2 on Tuesday, you are going to be a little bit more familiar with this, yeah, with how a laser works, yeah? If you remember from the Python course, where do I have it? We already explained it a little bit, this concept here in Python Essentials. Yeah, if you remember, if you attended to this class, yeah, this information here, yeah? And here we have the echo. Here you have all the information of all the parameters, etc. Okay? Yeah? Then, basically, this is a topic. Yeah? A topic is a channel where information from different ROS2 nodes flows. Yeah? And then a ROS2 node can either publish information into a topic or can subscribe to a topic to read the information. Yeah? Clear? So far, so good? Any questions? Any questions so far? Very good. Yes, perfect. Okay. Clear. Okay, then let's continue. So we have seen so far how to publish information to a topic, right? With the ROS2 topic pop. We have seen how to subscribe to a topic with ROS2 topic echo. And many more things like how to get information from a topic with ROS2 topic info, etc. But in order to publish information or subscribe to the information of a topic, doing it from the command line tools, it is useful for debugging purposes, yeah? But in general terms, what you are going to do is to create a program that does this, right? So the next step is how to create a publisher node. We are going to see right now how can we create a publisher using a ROS2 Python program, yeah? Then let's all together follow this example 2.4, yeah? So we are going to start by creating a new package. Okay, then where should I create my new package? Can somebody tell me? Where should I create my new package? Can I create it here? Can I create my new ROS2 package here or no? In SRC, says Jan. Okay, very well, very well. SRC directory, okay. So you saved me. You saved me because I was about to create it here. So thank you guys for letting me know. Then I'm going to go to ROS2 workspace. This you didn't tell me, okay? Everybody was saying SRC. How notebook workspace SRC, Lily? No, please. I need to go to the SRC directory of our ROS2 workspace. Okay? And notebook workspace is not a ROS2 workspace. Okay. So Lily says, in Notebooks workspace, this is not a ROS2 workspace. Okay. How do I know that this is not a ROS2 workspace? Can somebody tell me? How can I say that this is not a ROS2 workspace? Because I can tell Notebook workspace is not a ROS2 workspace. But how do I know this? There is no build install lock, exactly. Well, Misbah says there will be SRC folder in workspace. Yeah, but you can have SRC folders in other workspaces, yeah? But the key folders are specially built and installed, yeah? Then if I go to the ROS2 workspace, here I can see all the typical folders of a ROS2 workspace, which are build, install, lock, and SRC. Then I can tell this is a ROS2 workspace, yeah? Then I'm going to go to the SRC folder of my ROS2 workspace, and here I can create my new package. Okay? Let's go. There we go. So here we have our new publisher package. Then at this point, let's open the code editor, okay? Because it's going to be easier for us to work with code and so on, yeah? So, yeah. To open the code editor is the second icon here, yeah, right beside the terminal here, okay? Then let me go inside the ROS2 workspace, and here I can find my new package, publisher package. So let's continue. Then here we are going to create a new file named simplepublisher.py, okay? Where do I create this file? Where do I create this file? Can somebody tell me? Inside the test folder, maybe? In the publisher package. Okay, yeah. Inside the publisher package. Okay, then let's create here the new file. Simple publisher.py. Make sure that you don't have any space at the beginning. There we go. Okay. And then I'm going to copy and paste the code here to my Python file. Yeah. Then let's continue with the setup, and at the end I'm going to explain the code, okay? Next thing, I'm going to create a new launch folder here. So new folder, launch. And inside the launch file, I'm going to create a new, inside the launch folder, I'm going to create a new launch file with the following name. Publisher package launch file.launch.file. There we go. Okay. Yeah. Sometimes, I don't know why, the file got created outside the folder. Okay. In this case, if this happens, don't worry. You can just drag and drop the file inside the launch folder like this. Yeah. No big deal. And then I'm going to copy and paste the code for the launch file. Yeah. And then finally, I need to update my setup.py, right? This we already saw how to do it yesterday. So let's copy and paste the contents also of the setup.py. So I'm going to just remove mine and copy and paste. Yeah. Remember, the important parts are the console scripts here, where we are generating our executable, and this line here also, because here we are installing all the launch files in the ROS2 system, yeah? But this I already explained yesterday, so I'm not going to repeat all that. And then at this point, we are ready to compile. Remember, in order to build, where do I have to be in order to build my package? In which folder do I have to build my package? Can I build it here in the SRC? In ROS2 workspace. Okay, very well, very well. Thank you. Thank you for telling me. So I'm going to go back, and in the ROS2 workspace, here is where I'm going to build. Yeah. There we go. Okay, then meanwhile this finishes building, let me explain the code, okay? So what are we doing here? Well, first of all, we are importing RCLPy, the Python client library, and the node. Yeah? And also, I am importing the twist stamped message. Why? Because I'm going to be using this message. Yeah? Therefore, I need to import it. Okay? Then I create my class, which inherits from the node class. And then in my constructor, I initiate a ROS2 node named simple publisher. And here I am creating the publisher. Yeah? So I am defining that this node is going to have one publisher. Yeah? For this, I use the create publisher method. Yeah? And then here I need to specify a couple of things. First of all, what type am I going to be publishing? And to what the topic name where I'm going to be publishing. Okay? This number 10 is the queue size, but it's not so important right now. Okay? So I want to create a publisher, therefore I need to specify to which topic I want to publish and which type of messages I want to publish, right? And second, I am defining also a timer. Yeah, this one we already saw it yesterday. Yeah? Then I am creating a timer which is going to execute a callback function with a specific timer period, which in this case is 0.5. So this timer callback function, which I have defined it down here, is going to be executed every 0.5 seconds. And what am I doing in this timer callback function? Very easy. Here I create a message of the type twist stamped, and I provide some values to the linear x, in this case 0, and to the angular z, which in this case is going to be 0.5. Yeah? Then once I specify the values, then I publish my message. Yeah? Using the publish method from my publisher. From the publisher that I have defined here, I call the publish method in order to publish the message that I have just specified here. Yeah? And finally, I am printing a log message into the screen. Okay? And then here I have my main function where I initiate the ROS communication, I create an instance of my class, I spin the node until somebody kills it. Yeah? So I'm going to keep publishing these messages every 0.5 seconds into the topic ROSbot Excel base controller command bell. Yeah? Is it clear? Does it make sense? The code? Does everybody understand the code? Misba is asking, if I want to build only one package, what would be the command? Well, if you want to only build one package, the command would be like this. Colcon build, packages, select, and then the name of the package, which is publisher package. Yeah? This way, you are going to only build one package. Has the use of a timer callback with a timer period the same effect of using a loop? No. I mean, yes or no. Okay, this is a complicated question. Okay, so for ROS2, when creating a program in ROS2, you should try to avoid creating loops as much as possible. Okay? whenever you want to repeat a task, whenever you want to have a task which is repeated over time, you should always create a timer object. Okay? I mean, you could put a while here inside the main, but that would be not a good practice in ROS2. Okay? So in ROS2, whenever you want to create a repetitive task, use a timer. Okay? Not a while loop. Okay, just a little bit confused by code. Okay, it's normal. If all this is new, it's normal. Okay, just don't worry. Take your time, review the code, and you are going to understand it, I'm sure. Okay, then let me source, and now what I'm going to do is to run my program. So ROS2 launch, publisher package, and the name of my launch file. And whenever I execute my program, what should happen? That my robot should start rotating, right? So let's see. And there we go. There is an error. There is an error. Twist stamped object has no attribute linear. Okay. Does somebody know what this error means? Can somebody tell me what this error means? This is a bit more difficult, okay? But I want to ask anyways to see if somebody knows and is able to spot the error here. Topic list? No. Okay. This one is a bit trickier, so I'm going to explain it, okay? What is happening? Well, what is happening is related with the structure of the twist stamped message. Yeah? Let's remember the structure of the twist stamped message. Yeah? So here I am trying to publish, so from the twist stamped, I am accessing, so the message variable contains the whole twist stamped message. Yeah, this is clear. Then from the twist stamped message, I am trying to access a variable named linear, which is here. And then a variable named x, which is down here. Yeah? But I am missing something here, right? Can you spot what I am missing here? Also, maybe you can check it with the proto. Maybe it's going to be even more clear. Can you see what I am missing? Missing twist, exactly. Very good, Jan. So, in order to get to the linear variable of the message, right, first I need to access the twist variable, see? First it goes twist, then linear, and then x. Yeah? And the same for angular. First twist, then angular, and then z. Yeah? So here I need to add twist. And also for the angular, yeah, I need to add twist. Yeah? So let me recompile now my program. Yeah? Do you understand now the problem? Do you see? The twist. Okay, I can see more people saying it, yeah. Then source, install, setup bash. Let me execute again my program. There we go. And now we are going to see the robot start rotating, and my program now is publishing the velocity messages into the command bell topic. Yeah? Okay. So let's stop the program then, and let's continue. Then, next thing I want to show, so we have seen how to create a publisher, then how to create a subscriber. Okay, then let's do very quickly an example to create a subscriber. So let me create another package, cd, again, I need to go to the src folder, and here I create another package. And then inside this package, I'm going to create a Python script named simple subscriber. I'm going to go faster with this one, okay? Because all these are the same steps. Then I'm going to copy and paste the code. Here, I'm going to create my launch file. Yeah, so I create a new folder, launch. I create the launch file inside here. Let me move it to the launch folder. I put the code, and then I update the setup.py. Okay? Same steps that we have just done for the publisher. Then let's have a look here at the subscriber code. It is very similar, yeah? So again, we have all the imports, and in this case, instead of the twist stamped, we are importing the laser scan message. Why? Because inside our subscriber, we are going to subscribe to the scan topic, and we know, right, that the scan topic uses the laser scan message. Yeah? So, I create a node, a ROS2 node, and I create my subscriber. Yeah? I define my subscriber, and then I specify the type of message, the topic I want to subscribe to, and a callback function. Very important. Every subscriber has a callback function associated to it. Okay? This is the quality of service profile, but don't worry about this right now. Okay? You can just ignore it. Yeah? The important part here is you specify the type of message, the topic to subscribe to, and a callback function. Why do you have to specify a callback function? Because whenever a new message is received, is published to the scan topic, and my subscriber reads this message, a callback function is going to be triggered. Yeah? So every time a new message arrives to the scan topic, my subscriber is going to activate this callback function to do something. Yes? In this case, what we are doing is just to print this message into the screen. Yeah? But why is this? Because usually when you subscribe to a topic, what you want is to receive the information and do something with this information, right? This is why when you define a subscriber, you have to define a callback function associated to your subscriber. Yeah? Then in this case, my callback function is this one, and whenever a new message is published into the scan topic by the laser, my callback function is going to be triggered, and in this case here, what I am doing is to just print the message. Yeah? And then we have the main function with the same. Yeah, we are spinning the node, and that's it. Yeah? Do you understand this code? Is it clear? The subscriber code? Yes? No? Any doubt? Yes, yes. Very easy, right? Okay. Okay, then let's continue. Let me build my code, call build. Source, and then I'm going to execute my program here. There we go. and there we go, yeah? So my node is subscribing to the scan topic, and it's printing all the laser messages here, yeah? So for instance, now, if I do a ROS2 topic info of the scan topic, I'm going to see that there are 2 subscribers, right? And if I check more detailed information, I'm going to see that one of the subscribers is simple subscriber, yeah? One of the subscribers to the scan topic is the node simple subscriber, which, voila, is my node, yeah? The node that I am running, okay? Yeah? All right, so we have seen how to create a publisher, and we have seen how to create a subscriber, okay? Then here there is an exercise on how to combine a publisher and a subscriber, yeah? So this is the exercise. I'm going to define the exercise, but I'm not going to do it, okay? So let me introduce the exercise. Write a publisher and a subscriber node. Create a new ROS2 package named exercise 21 and add the following dependencies. Use the previous publisher to create a new code that makes the robot avoid obstacle in front of it. Get the real-time data from the laser and decide the robot's movement based on it. So if there's no obstacle in front of the robot, closer than 3 meters, move in a straight line. If front laser data is between 3 and 1 meter, reduce the robot speed. If the laser detects an obstacle in front of the robot closer than 1 meter, reduce the linear speed to 0.1 and start rotating the robot at 1 radian per second. Yeah? And the expected behavior is something like this. So we start moving the robot forward, and we are checking the value of the front laser data. Yeah? And whenever the laser data detects this obstacle in front of the robot closer than 1 meter, then I'm going to start rotating the robot to the right in order to avoid it, like you are going to see here. See? Okay? Then this is the exercise that you have to do, all right? And here you have the solution in case you have problems, yeah? Here you can see the solution where you are combining, you are creating a publisher and a subscriber in the same node, yeah? And then in the laser callback, you are saving only the data related to the front of the robot, yeah, which in this case is this range. And in the motion, you are checking the value of this laser forward, and depending on the value, you change the velocity of the robot, yeah? So this is the exercise. I'm not going to do it because I want to show you something else before we finish the class. And then this exercise, you should finish it before tomorrow, okay? You have it as homework. Then you have an extra part here at the end, which is how to create a custom interface, yeah? So we have seen some interfaces that are provided by default by ROS, yeah? Like the twist stamped, the laser scan, but it is also possible to create your own custom message, yeah? So here you have a guide on how to do it. You can do this if you want also or not. But now before finishing the class, I want to share with you the Roject, the project that we are going to be doing tomorrow. So I'm going to do this right now. Let me change my account. I'm going to share it in the chat, okay, here. Let me share it. Okay. So let me share here. Okay, so if you click on this link now, you are going to get already the Roject that we are going to be showing tomorrow. Okay? Which is this one. Then let me open it and very quickly show a couple of things to you, okay? why am I sharing this project with you? Because I want you to also start working on this project and try to have something working for tomorrow. Okay? Why? Because tomorrow we are going to connect to a real robot, and I'm going to allow some of you in the audience to connect to the real robot and test your code in the real robot. Okay? So if somebody achieves to have this project working for tomorrow, I'm going to allow you to connect. Probably not everybody is going to be able to connect because of limited time, but I'm going to allow some of you to connect to the real robot and try your code, okay? Then what do you have to do? Yeah, so for tomorrow's project, we are going to work with another simulation. Yeah, you are going to work with this simulation with a Turtlebot robot, okay? And then what you have to do is to achieve a simple patrolling behavior, okay? So here you are going to have to basically combine a publisher and a subscriber, which is the same exercise of today's class. You will have to combine a subscriber to the laser and a publisher to move the robot. And based on the laser data, you are going to have to decide what the robot does in order to move around this environment and avoid obstacles. Okay? So read carefully the instructions of the project and try to solve it, okay? With what we have learned today, you should be able to do it, yeah? And then tomorrow, I'm going to ask in the chat who has been able to have this working in the simulation, yeah? So first, you have to have it working in the simulation, yeah? And then, if any of you has this working in the simulation, I'm going to allow you to connect to the real robot and try your code in the real robot. Okay? Yeah? So is it clear, the homework that you have? First of all, you have to finish today's class, which is the Roject that we have been working with today. Okay? You have some work to finish on your own there. And once you have finished today's class, and you know very well how to combine a publisher with a subscriber in one program and so on, then you can start working on the project. Yeah? Is it clear, guys? Crystal clear. Yes, clear. Yes. Okay, awesome. Then from my side, I'm going to finish it here. Let me remind you very quickly before I finish that today is the last day for the early bird. Okay, so if you want to enroll to the Masterclass, today is the last day where you are going to have the early bird discount, okay, of 100 euros. And then you also have the extra coupon with the ROS2 Learning Week. But this discount, the early bird, it finishes by August 1, okay, so last day. Just a quick reminder. And then I'm going to finish the class today. I hope that you enjoyed it. Thanks again, everybody, for attending. And I will see you tomorrow. I hope that some of you have some code ready to be tested in the real robot, okay? Then tomorrow I will connect with you through a Zoom call, sorry, and then you will be sharing your screen and showing to everybody your program working in the real robot. So it's going to be super exciting, all right? So yeah, thanks one more time for attending the class. See you all tomorrow, and as always, keep pushing your robotics learning. Bye-bye.